Welcome to Quick Coder. My name is Tulasi. Today's topic is asymptotic notation part 2. So let's get started. Okay friends, now let's see. So what is big omega? So it tells the lower bound and it is the best case. So best case in the sense is it always says that in any case you cannot achieve better than this solution. So that is the reason it is the best case. So it always says you cannot achieve better than this. Okay, so the function f of n is equal to big omega of g of n if there exists a positive constant c and n naught such that f of n is always greater than or equal to c into g of n for all n greater than or equal to n naught. So now first let's see the graph here, okay, for big O notation. So let's say this is the n input size and this is the t. We have a graph like this or like this. So our algorithm goes like this. Let's say it is f of n and we can draw here some lower bound. Some lower bound is of this like like this. It is the lower bound c into g of n. Okay, so our algorithm will not go lesser than this, or it will not go in this place. Okay, in this place it will not go. Okay, okay, c of n, c into g of n. So now how can I say here, so let's say one example of the clarity. Okay, let's say f of n is equal to 2n plus 3. Here what they are saying, f of n should be greater than or equal to c into g of n, means our 2n plus 3 should be greater than or equal to some c into some g of n. So let's say like n as your and c as 1. Is it true? Yes, it is true, because 2n plus 3 is greater than or equal to 1n for all n greater than or equal to 1. Here our n naught will always be greater than or equal to 1 because the input should be at least 1 or greater than 1. Okay, now we got some g of n here, like this is c and this is g of n. Our big omega notation is omega of g of n. Our g of n is n. So this is the best case for the function 2n plus 3. Okay, the next so this is about big omega notation, and the next topic is the big theta notation. Okay, let's go into that. Sorry, another thing I forgot is here in the place of n we can keep root n, log n. See here, as our big O notation is n, you can go beyond this, but the tightest one is n, to choose n. So we can choose root n, log n, so something like that, 1. Okay, but the tightest one is n. Okay, so this is the lower bound, something lower. So the next topic is big theta notation. So let's go into that. Okay friends, let's get into big theta notation. So it is the average case, it tells the average case. So it is mainly used when the worst case and the best case are equal, and it tells the average bound. For example, it is the n, the input size, it is the t time. Our function goes like this. For example, our function goes like this, f of n. Okay, and we are fixing this average bound using some upper bound and lower bound. Okay, let's say we have upper bound like this. Okay, and we have some lower bound like this. Okay, like c1 into g of n, and this is c2 into g of n. Okay, so let's take this as n, this as n naught, where n naught is always greater than or equal to 1 because we should have at least one input. So now let's see the example here. So this our function should be f of n should be greater than c1 into g of n and less than c2 into g of n, as we already saw in the before examples. So this 2n plus 3 is less than or equal to 5n and it is greater than or equal to 1n. Okay, so our here also n and here also n. So our big theta notation is n as g of n. So this is g of n and this is c2, this is g of n and this is c2. Our big theta notation is theta of n. Here the theta is bound to this n only. Okay, see here our lower bound is less than or equal to n and our upper bound is greater than or equal to n, but our average case fixed to this n only. Okay, if we keep here log n and if we keep here log n, this will become false. See here 1 log n less than or equal to 2n plus 3 less than or equal to 5 log n. So as this is equal but this is not equal, this is equal, so this condition never true. So this log n never true. Only with 1n and 5n only it is possible. So our theta will be theta of n. So we quickly take one example and we can check the average case, best case and worst case. Okay.